bottom faces of the box. So let's do the top next. Top face. For the top face of the box, when we did the left and right face, we said on the right x was 0.01, on the left x was 0. How about on the top face? Well, on the top face, x starts over here at 0, but it goes up to 0.01. X changes. Sometimes x is over here, sometimes it's in the middle, and sometimes it's over here. So x varies from 0 to 0.01. X is a variable. So that means that our electric field, we can't fill in an x value. We have to leave electric field the way it is. 350 times x plus 130 j hat in newtons per coulomb. So there's our x. Our net electric flux is the integral of E dot dA. Can't take x out front because x is a variable. So next we have to sort out what do we mean by dA. Rather than draw on this picture, I'm going to redraw my box again. And let's see if we can get an idea of what we should put in for dA. There's our coordinate system. Here's our box, such as it is. So dA is a little bit of the area on the top face of the box. There's the whole area. We need to pick a little piece of the area. So for my little piece of the area, I'm going to pick a thin strip. So this little piece of area, it has a length equal to 0.01, and it has a width equal to a little bit in the x direction, a width of dx. So the area of this little strip is 0.01 times dx, and it has a direction. The direction is straight up, dA. So dA, and we're saying dA because it's a little bit of area. If it were the whole area, we'd call it A. So dA is the length, 0.01, times the width, dx, with the direction up, which is j hat. So there's what we know for dA. So let's put in this for E, let's put in this for dA, and let's find our net electric flux. Equals the integral of 350 times x plus 130 j hat dotted with 0.01 dx j hat. Let's pull the numbers to the front, the j's to the back. 350 x plus 130 times 0.01 times dx j dot j. J dot j, when you dot a unit vector with itself, you get 1 because they're parallel. So that means this part is 1, so now we'll multiply this 0.01 through. So 350 times 0.01 gives us 3.5 times x. 130 times 0.01 gives us 1.3. Those are times dx. Now we've got an addition inside our integral. We can split that into two integrals, 3.5x dx plus the integral of 1.3 times dx. Let's fill in the limits of our integral here. We said that x varies from this side to this side. It goes from 0 to 0.1. So let's evaluate our integral. The integral of 3.5x is going to be 3.5 times x squared over 2, and that's going to be evaluated at 0.01 and 0. The integral of 1.3 is 1.3x, evaluated at 0.01 and 0. So 3.5 times 0.01 squared over 2 plus 3.5 times 0 squared, minus, over 2 plus 1.3 times 0.01 minus 1.3 times 0. All that through the calculator, and what we should get is 0.01318. So there's the net electric flux through the top face of the box. Next, let's do the bottom face of the box. So the bottom face of the box, why don't we do that picture real quick. Our bottom face of the box down here, so bottom face, hopefully we can make this one a little bit quicker. X also varies from 0 to 0.01. So our electric field is equal to 350 times x plus 130 times j. It's a variable. We don't have a number for x we can fill in. Our net electric flux is the integral of E dot dA. We know what to fill in for E. What are we going to fill in for dA? Let's pick our area element to be similar to what we did before. Let's do a thin strip, but it's on the bottom of the box. Since it's on the bottom, the direction is down, points down out of the face. dA is still length times width. The length is from here to here, 0.01. The width is from here to here, dx. But now the direction is minus j, because it's down out of the face. So our area is minus 0.01 dx j hat. So let's put this in right here. So that gives us 350x plus 130 dotted with j times j dotted with minus 0.01 dxj. I'm going to take that minus sign out front, minus integral 350x plus 130j dotted with 0.01 dxj. Now if we look at what we did a second ago, this is the same as this, but this has the negative sign in front of it. So let's just jump and use the result that we had last time. And the result we got was that the net electric flux was 0.01318. So here our net flux is minus 0.01318. You can go through this process again for practice if you want to, but you certainly don't need it to. So what we have so far is the flux through the right and left faces, top and bottom faces. All we have left is front and back faces, and then we'll add them up to find the net flux. We'll do that part next.